inverse trigonometric functions. And the thing is they're not very difficult. All right, guys. So we're on this part for inverse trigonometric functions. It's going to be pretty straightforward. So these functions are pretty much called Arcus functions, anti-trigonometric functions, or psychometric functions. We refer to them as arc functions, and you think about it like typically we're using these trigonometric functions to get the length of an arc, but here we're looking at angles, right? So let me find the pen here and get myself organized. So these functions here, the basic ones you'll have to remember are the ones on the left, the far left. One's in the second column and the third column. The third column becomes more important as you move forward. Maybe with in that second part of uh, of integrals and stuff like that. But right now, the two main columns you want to be like cognizant of are these two. So remember, you'll see me interchangeably um, when we have a composition involved. Interchangeably go from u to g of x, and just being mindful that u prime equals g prime of x. All right. Um, so here, the way we'd write this, you could write however it's easier for you to recall this, but this is just 1 minus g sub x, and that's squared, and it's times, this is all times the derivative of g of x. For this composition, for this inverse of g of x, we're going to have equals negative 1 over um, the square root of 1 minus g sub x, and I'm putting this in hard brackets, squared, times g prime of x. Similarly, looks very similar to this, except it's 1 over 1 plus g of x squared, and not just x squared, times the derivative of, and this would work for x as well. So if you get the derivative of x, it's just going to be x. It's going to be 1, right? So we don't even acknowledge it. It's like saying 1 times out here, and then x squared instead of g of x squared. So that is why it's that way. This equals 1 over the absolute value. Remember, x will be g of x out here. Square root of 1 minus g of x, and it's squared, and then times g prime of x, of course. Similarly here, this equals negative absolute value of g of x, 1 over the square root of 1 minus g of x, and of course it's squared, times g prime of x. And of course you could put this in the numerator each time, as I'm going to do in the last one. So I'll say g prime of x over 1 plus g of x, and if you notice, hard brackets once again, squared. I'm only going to do one of these for this x over a. So here we're looking at replacing this 1, so this becomes a. This equals the absolute value of a, whatever a is, square root of a squared minus x squared. Similarly, with the cosine, it's just negative absolute value of a over a square root of a squared minus x squared. And we won't worry about these other ones, but primarily you'll be looking at these. So keeping that in mind, you can go through here. We're not going to worry about the proofs here. What we're going to worry about is you memorizing that the derivative of the arc sine of x is 1 over the square root of 1 minus x squared. The derivative of the arc cosine is equal to negative 1 over the square root of 1 minus x squared. And the derivative of arc tangent is positive 1 over the square root, because it's like saying those two things over each other. Let me erase this. 1 plus x squared. And like I said, it's like saying sine, the arc sine over the arc cosine, or negative 1 over the square root of 1 minus x squared over square root of 1 minus x squared. And that's how we get all of this. Okay, so we're not going to worry about that. All right, I want to get to the problem. So this is a obviously arc sine of g of x. So sine, I'm going to do this composition and call that g of x. So g of x here equals 5x. G prime of x equals 5. So if I'm going to put this in the formula here, it's g prime of x. And you're like, Miss Smith, you're so amazing. How do you memorize all this stuff? And I'm just going to tell you, I don't know. I think I'm crazy. Anyways, so plugging stuff in, guys. 5 over the square root of 1 minus 5x. And that's squared. And yes, let's simplify this because we can, because we're bosses like this. And we get 1 minus 25x squared. And if you notice, this is a difference of two squares. So yes, you could factor it out, but we want to just kind of keep it like this. So let's look at number next. We have g of x equals 2x plus 1. And I'm going to put this into exponential form. So g prime of x is going to be equal to 1/2 times 2x plus 1 times 2, and this is to the negative 1/2. If you want to, those 2's going to cancel. I'm going to have 1 over the square root of 2x plus 1. So that's my g prime of x. Now, this is going to be y prime is going to be equal to, and make sure I put y prime over here. All right, so g prime of x is 1. So let's write this out. This is why we multiply this g prime of x and don't just put it in the numerator, because of instances where we get this kind of bizarre behavior here. So 1 over 1 plus g of x squared, so 2x plus 1 to the 1/2, and that's squared. That just means it just comes out of the radical. This equals 1 over 1 plus 2x plus 1, right? And times what's on the bottom, square root of 2x plus 1. So I'm going to simplify, and I get 1 over square root of 2x plus 1. I'm just going to write it first because it's easier. And then 2 plus 2x. And done. Let's look at number next. So g of x is pretty easy here. This equals x squared. G prime of x equals 2x. And I'm going to write it out to the side. So 2x out to the side times 1 over the square root, and this is negative, of 1 minus x squared, and it's squared. This equals 2x, negative 2x over the radical of 1 minus x to the 4th. Number next, I have g of x equals x squared minus 1, g prime of x equals 2x. I get 2x over the square root of 1 minus x squared minus 1, and that group is squared. And I'm not going to simplify that because that's a lot of work. Number last, or a couple number last here, g of x is cosine of x. G prime of x is negative sine x. So I'm going to write this out to the side, times, put a little parentheses there so I don't mistake it for subtraction. 1 over 1 plus, let's see, cosine x squared. Simplify, that's going to give me negative sine x over 1 plus cosine squared x. Okay? Let's look at number next. This is number last. So g of x and g prime of x are going to equal each other. So I'm not going to worry about it. So 1 over 1 minus e to the x, that's squared, and radical over that, times e to the x, that's going to equal e to the x over square root of 1 minus e to the 2x. Okay? And now we're going to work on a tangent line. So remember, we're going to call this f of x because I just love doing that, getting rid of that y. So I want to find f prime of x, f prime of 2, which equals, let's write this tangent. Let's write this tangent here. And this is x over 2. So we're just going to put it in the form that we have. So remember, arctan is 1 over 1 plus x squared. Now, this x is going to become x over 2. We're going to square it. And the derivative is going to be 1/2. Okay. I'm going to make sure I took care of everything. So g of x here is x over 2. G prime of x is just 1/2. All right. So there's like a formula for this, but we're just going to try to go this route and see if we end up with the right thing. All right. So we have 1/2, 1 times 1/2, 1 plus, let's see, x squared over 4. And I'm getting all that from right there. All right. So I said we want to get this derivative. So 1 over 1 plus 2 squared over 4 times 1/2. This equals 1 over 1 plus 1 times 1/2, and it equals 1/4. Okay, so I have the slope, I have the point of tangency, so y minus pi over 4 equals 1/4 times x minus 2. And I'm done. And I'm done. And that's it. That's all she wrote, guys. Next lesson is going to be for activity 4, and that lesson is going to be on higher derivatives. Easy peasy, bright and easy. Have a good one, guys. You should have enough time to finish everything. Make sure you do homework on inverse functions and delta math.